Hey, it's Hagen with TOPDON. Today we're going to do a quick video showing you a diagnosis on a brake pedal position switch. Now, this particular system is used on a wide variety of different vehicles. Sometimes the switches are mounted on the brake master cylinder. Sometimes they are mounted down by the brake pedal itself. Every vehicle is going to be a little different, so you always want to make sure you consult the service information, including the wiring diagram as well as the description and operation for the given component that you are diagnosing. Now, today's video, we're going to use the TOPDON Phoenix Series Scan Tool, specifically the Phoenix Smart. However, you can use any of the TOPDON Phoenix Series professional tools for the live data analysis portion of this, and any of the Phoenix series tools that are compatible with the TOPDON Phoenix Oscilloscope. So let's go ahead and we're going to take you through our basic initial pre-scan, some live data that we looked at, and then eventually we'll get to an oscilloscope demonstration. So today's vehicle, I'm going to move my bubble out of the way. Today's vehicle is a 2014 Volkswagen Passat. The vehicle has a couple of different fault codes stored, and currently there are a bunch of warning lights on the dash. It also does not have cruise control functionality. So, customer wants to get to the bottom of this and find out why the vehicle is broken. So, on our pre-scan here with the Phoenix Smart, we come up with a couple of different fault codes. So we have a P0571, which is stored in the engine control module for the cruise/brake switch A circuit malfunction. We also have a fault code in the brake electronics, which is the anti-lock brake control module, 00526 for brake light switch implausible signal. Okay, so we got to find out, why do we have these faults, right? First thing we got to understand is, how does the system work? And to that point, typically where I go first is a wiring diagram. So this particular vehicle has two brake pedal/brake light switches, F as in Frank and F as in Frank 47. They are both contained inside one housing here. You can see that's why the box is drawn as one continuous box. Every component we deal with in electrical terms is going to require power and ground. So we have 4 wires coming out of this assembly. There's 2 separate sensors, and both sensors are going to need power and ground. That means out of the 4 wires, we have a power, we have a ground, and we have 2 signal wires. So, pretty straightforward, right? 4 wires, 2 signals, power, and a ground. Okay, so in order to find out why we have this fault code, we're going to do a couple of different tests. First off, we're looking at where do these signals go. So if we look in the wiring diagram here, we can see the one signal branch goes off to a couple of different modules, including the engine control module, the body control module, and the ABS control module. Now, I have not shown you the whole wiring diagram here, so you can see down on the bottom there's these 2 numbers showing where these other tracks go. I'm not going to show you the rest of the diagram, but those are the other modules it goes to. Up at the top, we have the engine control module here. So you can see the red-black wire goes there, and then it branches off and goes to these other 2 places, which again are the VCM or J519 and ABS module. So the second leg or the second sensor goes directly to the ECM. So the ECM sees both signals, and the body control module and the ABS see one signal directly. It's also possible that status of each of these 2 switches may be communicated over the vehicle communication network as well. So just keep that in mind. So what does it tell us about how the system works? A couple of different things we're looking at here as we're going through our testing. We're checking to see if the brake lights on the vehicle function, and do they function when we're pressing on the brake pedal. In other words, if we step on the brake pedal, do the lights come on? And when we release the brake pedal, do the lights go off? And does this happen consistently and correctly each time we step on or release the brake pedal? That's the first thing we want to look at. It's the simplest clue we can look for. Now we see that the switch, each of those two switches, feeds directly to the ECM. So we know that the ECM is monitoring both. Why would it monitor both? This is actually a fail-safe or driver protection measure, and this has been done on Volkswagen Audi for a good long period of time. Other vehicle manufacturers have also implemented this same kind of setup for a good reason. This is a fail-safe or a driver protection measure. Basically, the modules that are watching these signals are paying attention and potentially communicating over the vehicle communication network for the purposes of verifying that both of these switches agree that the brake pedal is or is not being depressed. Why? To make sure that we don't have unintended acceleration. If the customer or owner of the vehicle is attempting to stop the vehicle, we want to make sure the modules can accurately recognize that the brake pedal is being depressed. Therefore, these two signals are being compared at all times to determine whether or not the vehicle is actually trying to be accelerated or not. Additionally, we can look in the live data stream for each of these different modules and verify that the status input to each of these is reading correctly or consistently with what we are doing with the brake pedal itself. And again, we can compare the data in each of these modules one at a time. So if we find something erroneous in one module, but not another, and the fault is present, then we know it might be a wiring problem, since the wires are independent to some extent. If, however, we have consistent anomaly readings between multiple modules, then we may have either one of the two sensors has a problem, or we might have a problem with the sensor reading correctly against the reference surface, which is inside the brake master cylinder on this car. We're going to move my bubble out of the way here. And again, we're just trying to find out, is the status we're seeing on the scan tool as well as the brake lights themselves matching up with what we're doing with the brake pedal? So the first thing we look at here is we're going to go into the engine control module and we're going to look at the live data. Now we did a little search and we found a data PID for brake pedal status. Now here you can see the brake pedal status has two distinct positions, not operated or active or operated. So we can see it switches from not operated to operated and then back again. Now again, as we're doing that test, we want to make sure that that's matching up with what we're doing with our foot. So then we go into the ABS control module, and we didn't have the fault present when we were checking the ECM data, but when we went into the brake control module, now we are pressing the brake pedal again, and we get it to stick. And when I say stick, I mean the data PID is showing that the brake pedal is activated, but we are not pressing the brake pedal. So at this point, we could back out of the brake control module, and we could go check in the ECM again and see if the ECM agrees with this or disagrees. Simple things that we can check here to verify what's going on. So what else can we do to test this? We verified that we can see there is an active problem. The fault is present. We let off the brake pedal and it stays activated, even though in fact it's not activated by our foot. We know that the signal is malfunctioning in some way. We don't know if it's the sensor. We don't know if we have a wiring problem. We don't know what's going on. So we need to perform some additional tests to find out. Now there's no faults in the body control module, so that's kind of strange, right? We don't know if that has any meaning or value yet. More likely than not, we have a signal integrity issue, right? We probably have one of the two sensors is sticking in the signal it's sending out, or perhaps both sensors are sending erroneous data, or we could be losing power or ground. We don't know yet. The oscilloscope, on the other hand, can be used to collect this information and basically give us a lot of insight all in one simple test. So basically what we're going to do is we're going to take the oscilloscope and use one of each of the four channels to connect to one of each of the four wires at the sensor in order to determine what's going on. Now, a couple things we want to remember about the test before we go into the live demonstration portion here. I'm going to move my bubble again to get it out of the way. First off, we want to understand that where we connect the oscilloscope to the circuit is going to affect the meaning of the signal that we're collecting with the oscilloscope. If we connect the oscilloscope directly at the sensor, then we know what the sensor is producing, and also whether or not the sensor is receiving a proper power or ground, correct? If we connect at one of the modules, so remember, the sensors are sending out signals to multiple modules. If we connect the oscilloscope back at one of those modules, then we can see what each of those modules is seeing. So that tells us if the signal is actually getting to the module itself correctly. Here in what we're going to do in the live demonstration, we're going to start by showing you what's happening at the sensor on a known good vehicle, so you have something for reference. We're also going to show you a faulted vehicle so that you can have an idea of what you might see when there is a problem. We're also going to talk a little bit about other testing strategies that you can employ here in order to determine whether or not it is a sensor problem, a wiring problem, or something internal to the master cylinder itself. Again, we're going to walk you through the basics as far as the setup goes in our live demonstration here, but this is just a little bit of information for your reference. Again, when we're doing the test and we have the scope all set up, we want to make sure we press the brake pedal repeatedly so that we can see what is physically happening on all of the four wires, the power, the ground, and both of the signals. That way we can determine if there is a problem with any of those. Hey, Hakan with TOPDON. We're just going to do a quick live demonstration here. So I'm going to leave you here watching on the screen. We're going to set you up so that you can see the scope screen on the TV behind me here. And I am going to run the test on the brake pedal position sensor on the TOPDON scope. So we'll show you how we have it hooked up on the car, and then we will show you the sensor in action and how we are able to use the scope to basically check everything all simultaneously using all four channels on the oscilloscope. So let's go ahead. We'll show you at the car here first, and then we will show you the scope capture itself. Okay, so we are over here at the car, and we're just going to walk you through how we have this set up. Down inside here, we'll zoom in, and you can see right there, we have the sensor disconnected. And basically what we have is 4 jumper leads so that we are bridging the connections between the connector that normally plugs in there and the sensor itself. And they have breakouts so that here we can attach oscilloscope channels to each of the pins of the sensor. The sensor has 4 pins, 1 power, 1 ground, and 2 signal wires. So what we're going to do here is show you over here on the scope. So we have 1 channel, again, on each of the 4 sensor pins. We only have 1 ground. That is coming off of the blue lead. So you see the black wire here, this is a ground. We are only grounding 1 of the leads because the TOPDON scope is a shared ground unit. So again, this is a shared ground unit, so you only need 1 ground that goes across for all 4 channels. So we're just going to ground the blue lead. If we had grounds attached, so you see here on these leads we're using today, they do not have grounds attached by default. But if we attach leads to this for ground, those grounds would need to go to the same place as the ground that is coming off of the blue lead. In this case, battery negative. So again, because the TOPDON scope has a shared ground internally, we need to make sure all of the channels are grounded to the same place or only ground the 1 channel. So now that we've shown you the setup here, we're going to take you over and show you what's happening on the scope screen. Okay, so now we're going to show you what's happening on the scope screen here. I'm actually standing here at a giant TV, which I am using the wireless screen projection function on the scope
to display. So we're just going to talk you through what we have set up here. So over here on the scope, we have 2 seconds per division. So as we look across the screen here, we have 20 seconds of time. Here's the 0 mark. So 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds, right? I have also configured measurement parameters for minimums and maximums for all 4 of the channels. Each of the channels is set to a voltage range. I've got 10 volts on this channel here per division, 5, 5, and 5 on all the other ones. Now currently the scope is running, and you're going to see me press the brake pedal, and you will be able to see what's actually happening on the screen here. So you can see now I'm in the car here, and I'm going to press the brake pedal repeatedly. And we can watch and see what happens here. I'll jiggle it kind of quickly. But we can see what's happening to the signal here. Basically, it's going to switch high on one of the 2 sensors and low on the other of the 2 sensors, and they should always be directly opposite of each other. Now, on the other 2 channels you can see here, on the very top of the screen there, we've got channel 1, which is this yellow here, and that is a ground, and channel 4, which is on the bottom here, is actually a power supply. And remember, we said the sensor has a power and a ground and 2 sensor circuits. So if we had a fault here actively happening on this car, we would be able to see if either the power or the ground was dropping out during the fault happening. In this case, there's no problem with this car, so both sensors switch opposite of each other at all times, and our power and our ground remain steady and clear. So in this particular case, we don't have any concerns, and it's very easy to prove this with the scope. So it's really good that you can hook up your scope, all 4 channels, and see everything happening for that sensor simultaneously.
Okay, so now we're going to show you a vehicle that has active faults, and you can see what's happening with the signal. So here's a vehicle that is active faults. Now in this particular case, we did not put the power or the ground to the sensor on the screen. We only put the 2 signals. Now, we did verify that we were not losing power or ground at any time, even though those are not displayed on the screen currently. We did verify that, and there were no issues with the power or ground. We can see over on the left side of the signal here on the vehicle that has a problem, we see one sensor switching high while the other switches low, and it's working correctly over on the left side of the screen here. However, when we get over to the right side of the screen here, we have a signal problem. Now, we don't know if this is only a sensor problem simply by looking at this waveform. So just want to wrap up with our conclusions here. We showed you the scope setup on a known good vehicle. We demonstrated what you should see on a known good vehicle. We also showed you what a problematic waveform may look like on a given vehicle. Now, of course, it's important to understand you can get all sorts of problematic waveforms, right? We can get low signal amplitude, right? We can get the waveform not switching high and low on the sensors. We can lose power or ground. Any of those are possible. However, let's talk about just a couple of things to wrap us up for today. If the waveforms are collected directly at the sensor, like we did today, and we have a problem with the signal, we want to ask ourselves, are we losing power or ground? If we're not losing a power or ground, then we know we don't need to test anywhere upstream, such as at one of the modules or anywhere else in the wiring. Because if there is no good signal being produced, then we know there is a problem right there, either with the sensor or the reference surface, which in this case is inside the master cylinder. If we spot anomalies on both of the signals, we need to check and find out if this is internal to the master cylinder or if it is a common failure within the sensor. Generally speaking, we're not going to remove the master cylinder to check this. It's possible, you can do that. You can see if there's oscillation or play in the shaft of the master cylinder if you remove it. However, again, this is typically not a very efficient way to analyze what's going on. So let's talk about a few other ways we can divorce the problem from the sensor versus the master cylinder. Checking the sensor to make sure it is properly mounted directly to the master cylinder is critical. If there is clearance that there should not be, that's going to affect the signal integrity of the sensor. Assuming the sensor is mounted correctly to the master cylinder, if that is okay, then we can disconnect the sensor from the master cylinder, unscrew the mounting bolt, disconnect the sensor, and then we can wave a ferromagnetic object, such as a screwdriver, in front of the sensor repeatedly and see if our signal is normal square wave, switch high, switch low on each of the two poles, or if we can replicate the anomaly simply by waving the screwdriver in front of the sensor. If the waveform is normal square wave, high and low, when we wave the screwdriver in front of it, then we know the sensor is okay. If the waveform is abnormal, no matter whether it is bolted to the master cylinder, the sensor, or us waving a screwdriver in front of it, then we know the sensor is the problem. So this is the way that you can divorce the two between a sensor problem or an internal master cylinder problem on this given vehicle. Again, some vehicles may have the sensor mounted down at the brake pedal instead of on the master cylinder, but the testing principles are going to remain the same here, assuming your sensor is set up the same way. So hopefully this has helped you diagnose and determine what is the root cause of these two fault codes on a Volkswagen. Again, this is a general video and applicable to this specific vehicle, but the concepts can be used on a wide variety of different vehicles. So just wanted to say thank you for taking the time to watch this video as always. And again, I'm Hawken with TOPDON. Please like, subscribe, and share, and we'll see you on the next video.